Hi, this tutorial serves as a linear equation algebra review. Alright, so the construction and use of best fit lines requires some algebraic knowledge. Let's review the algebra needed to understand linear equations. Alright, you may have seen the general form of a linear equation as y equals mx plus b. Okay, that's pretty standard from algebra class, where m represents the slope of the line and b represents the y-intercept of the line. Okay, x is usually your independent or your explanatory variable, y is your response variable or your dependent variable. Okay, now statisticians prefer to use different notation for the general form of a linear equation. What they use is y equals b with a subscript of 0, so b sub 0, plus b with a subscript of 1 times x. So b0 plus b1x, or b sub 0 plus b sub 1x, where b1 represents the slope of the line and b0 represents the y-intercept of the line. Okay, so really if we're making some comparisons here, b0 is the same as b there, and m is the same as b1. Okay, so they really tell you the same thing. They're just in a different order and using different letters. Okay, now to just review what slope and y-intercept are. So slope is a measure of a line's steepness. It measures the change in y for a 1 unit increase in x. Okay, and the y-intercept is the y value when x equals 0. Alright, so now let's actually look at an equation. So suppose you're given the equation y equals negative 2 plus 3x. So being able to graph this equation is an important skill. An easy way to graph a line is to produce 2 points, then draw a line through those 2 points. Let's try it. Okay, so let's start with this equation, y equals negative 2 plus 3x. Okay, so again, all we need is 2 points. So let's determine 2 points, and you can really pick any x values you want. So the values I'm going to pick are x equals 2 and x equals 5. Okay, so to get the y values, all we need to do is substitute the x value into the equation. Okay, so this is going to be negative 2 plus 3 times 2, and negative 2 plus 3 times 5. Okay, now if we do that, 3 times 2 is 6, plus negative 2 is 4. So y is going to equal 4 when x is 2. And then here we have 3 times 5 is 15, plus negative 2 is 13. Okay, so the 2 points, 2 of the points that are going to be on this line are 2, 4, and 5, 13. Okay, so now if we want to graph that, let's just set up a set of axes and plot those 2 points and then draw a nice straight line through it. Okay, so I'm going to do that over here. I'm only going to need the first quadrant of my graph, so I'm going to make my x and y axes like so. And my x-axis needs to go from 2 to 5. Okay, and then I need to get up to at least 13 here. Okay, and then all I need to do is plot my 2 points, 2, 4 and 5, 13. So 2, 4 is going to be here, and 5, 13 is going to be about here. Okay, so those are the 2 points that are going to be on the line, and then I'm going to use a ruler to draw a nice straight line that goes through those 2 points. Okay, put my arrows on there to represent the line continuing. So this is the graph of y equals negative 2 plus 3x. Okay, now another important skill involving linear equations is to create an equation for a line that passes through 2 points. So let's determine the equation of the line that passes through 2, 4 and 5, 13. Okay, so I've picked the same points we used in the last example, but let's go backward and see if we can come up with that equation now. Okay, so the first thing that is important to do is to determine the slope. Okay, so remember we said the slope is equal to b1. So let's determine the slope first. So remember the slope is always the change in the y's divided by the change in the x's. So it's the change in y divided by the change in x. So if I wanted to determine the change in the y values, if the y are changing from 4 to 13, to determine that change, I could subtract those two values. Now I need the change in x's on the bottom of the fraction. So if we're changing from 2 to 5, I can subtract those two values on the bottom here. Okay, so now if we do that, we get 13 minus 4 is 9. 5 minus 2 is 3. So 9 divided by 3 is 3. So my slope, b1, is 3. Okay, now what I need to do is determine what my intercept is. So now I'm trying to figure out b0. Okay, now what I'm going to do is I'm going to use my general equation, or the general form for a linear equation, and I know what b1 is. I don't know b0, and for x and y, all I really need to do to solve for b0 is plug in a point. So plug in 2 for x and 4 for y. So I'm going to do that here. So I'm going to use 4 for y. b0 is unknown, so I'm going to leave that as b0. b1 we know is 3. And for x, we're going to use 2. Okay, you can't mix and match the x and y's from different points. We have to use the same we have to use an x and a y from the same point. Okay, so let's do this multiplication. So that's 6. And now all I need to do is use some algebra to solve for b0. So the algebra I'm going to use is I'm going to subtract 6 from both sides. So 4 minus 6 is negative 2 equals b0. 6 minus 6 is 0. So b0 is equal to negative 2. So now I have a slope and I have a y-intercept. So this is my y-intercept. Okay. So finally I can write my equation. So it's going to be y equals b0. So b0 is negative 2 plus b1 is the slope. So that's 3, and then my x. So this is the equation for a line that passes through the points 2, 4, and 5, 13. Okay, and that was the same equation we had before. Okay, now the last thing I want to discuss is how to think about an equation with the variables reversed. Okay, so let's consider this equation. Income equals 2 times sales minus 100. Okay, so this is, instead of using x and y, I'm using two variables. So I'm using a variable for sales and a variable for income. So it doesn't matter what I'm calling x and y, I'm just putting them in as the values. So this equation shows income as a function of sales. Okay, so to determine income, you need a value of sales. But now what if we wanted an equation for sales as a function of income? What would the equation, or would the equation look the same? Okay, so if I wanted an equation for sales equaling something with income, what I would need to do is reverse the two equations. Okay, so I'm going to have income equals 2 times sales minus 100. Now if I'm solving this for sales, first thing I need to do is I need to add 100 to both sides. Okay, so now what I'm left with is income plus 100 equals 2 times sales. Okay, now the next algebra step I need to do is divide both sides by 2. Okay, now what I'm left with is income plus 100 divided by 2 equals sales. So now my equation is an equation for sales as a function of income. Now are these two equations the same? No, they're not. They look pretty different. This one has addition and division. This one had subtraction and multiplication. So this looks a lot different than that. So it's important that if you're writing an equation, determining what value goes on the x-axis and what goes on the y is going to have a pretty big effect on your equation. Okay, if you think back to correlation, switching x and y won't affect your correlation, but it will affect your equation. All right, well that has been your algebra review on linear equations. Thanks for watching.